Have you ever imagined that a ship could cross a desert? Amid the arid Egyptian desert, a nearly 200-kilometer stretch of blue water lies across it like a ribbon, shaping the map of global trade. That is the Suez Canal, the man-made lifeline connecting the Mediterranean Sea and the Red Sea, creating a strategic shortcut for ships between Asia and Europe. And it is the route that carries up to 14% of the world's goods. Every day, dozens to hundreds of giant ships still quietly crawl through this narrow stretch of water, making it one of the busiest maritime routes on the planet. And with just a small incident, the entire global supply chain can immediately be shaken, causing billions of dollars in damage. In this video, let's join Mandarin Tech to explore the Suez Canal, the engineering marvel that has changed the history of trade, shaped geopolitical power, and proven that human intelligence can carve a path even through vast desert landscapes. The Suez Canal is not just a canal, it is the dividing line between two worlds, where 100-meter-long container ships carrying the heartbeat of global trade glide past just a few steps from the burning desert. With its unique strategic position, this man-made waterway shortens the distance from Europe to Asia by more than 7,000 kilometers, allowing goods, energy, and strategic materials to move in just a few days instead of several weeks around the Cape of Good Hope. The idea of connecting the Mediterranean Sea with the Red Sea more than 3,200 years ago, when the ancient Egyptians wanted to open a canal route that would help ships travel more easily from the Nile River to the Eastern Sea. Many centuries later, the pharaohs and the emperors of Persia, Greece, and Rome continued to expand or restore this ancient canal. But due to siltation, changes in water levels, wars, and the decline of empires, those canals were repeatedly abandoned. By the late 18th century, when Napoleon Bonaparte entered Egypt, he was the first to propose a modern canal cutting across the desert. The engineering team began surveying, but a serious measurement error led them to believe that the Mediterranean Sea was 9 meters higher than the Red Sea. If the canal were dug, seawater would flood in and cause a disaster. Therefore, the plan was quickly canceled. It was not until the mid-19th century that the project truly began, when Ferdinand de Lesseps persuaded the Viceroy of Egypt to grant construction approval. Over the next 10 years, more than 1.5 million laborers worked on removing a total of 2.613 billion cubic feet of soil, of which 600 million cubic feet were dug by hand in harsh desert conditions, and 2.013 billion cubic feet were handled by steam dredgers, the most advanced mechanical technology of the 19th century. In 1869, the Suez Canal was completed, marking an impressive combination of human effort and industrial machinery. After the project was launched, the first challenge the engineering team faced was the Port Said area. This was a low-lying region with water depths of only 1 to 1.2 meters and a seabed made of soft mud and clay deposited by the Nile River. This made dredging, stabilizing the canal banks, and utilizing the excavated material extremely complex. Although the canal was officially completed in 1869, expansion and improvement continued for more than a century, and the canal's current cross-section is now 15 times larger than its original size. As they moved deeper into the Isthmus of Suez, the limitations of 19th century became increasingly evident. When Ferdinand de Lesseps initiated the project in 1859, the entire region was almost uninhabited, lacking infrastructure, and even fresh water had to be transported from far away. All construction materials, machinery, and mechanical equipment had to be delivered by ship and then transferred across the desert. In addition to harsh natural conditions, the labor force at the construction site constantly faced disease, water shortages, extreme temperatures, and numerous labor crises. Thousands of workers died during the construction process, a devastating price for the ambition to create the most important waterway of the 19th century. Nearly 150 years after the Suez Canal officially entered operation, the rapid growth of global trade meant that this waterway could no longer meet demand. A major issue that had existed for decades was that the canal was too narrow for two large vessels to sail side by side, forcing ships to wait at passing points, causing congestion and extending transit time to up to 18 hours. In 2014, Egypt decided to undertake one of its boldest infrastructure projects, expanding the Suez Canal and constructing a new parallel waterway. The project was divided into two parts: excavating a new 35-kilometer canal running parallel to the original route to create two-way traffic, and widening and deepening the remaining 37 kilometers near the Great Bitter Lake area to increase the canal's width and capacity for ultra-large vessels. In the middle of the Egyptian desert, a massive construction site rose within just a few months. The Egyptian military and international contractors mobilized bulldozers, trucks, and excavators working around the clock to level the terrain and move and process more than 250 million cubic meters of sand, soil, and rock. Once the new route reached the required elevation, the area where dredging vessels could access it. The most critical part was underwater dredging, using dozens of the world's most advanced dredging ships, cutter suction dredgers, and trailing suction hopper dredgers. These giant floating machines, more than 200 meters long, used high-power cutting heads to break up the seabed, then suctioned and pumped the material over distances of several kilometers through floating pipelines. In just 12 months, Egypt completed more than 200 million cubic meters of dredging, an unprecedented record in maritime engineering history. In August 2015, the new Suez Canal was officially inaugurated, allowing two-way vessel traffic along a total of 72 kilometers, reducing transit time from 18 hours to only 11 hours, and cutting waiting time from 11 hours to just 3 hours. This project not only doubled the canal's capacity, but also reaffirmed Suez's strategic position as one of the world's most critical maritime trade routes. The Suez Canal is one of the busiest transportation arteries on the planet. Each year, around 18,000 ships from all over the world pass through this waterway, turning it into a maritime highway, operating almost continuously around the clock. The total volume of goods transshipped reaches about 700 million tons, including crude oil, natural gas, bulk cargo, containers, and high-value industrial products. Notably, the ships that travel through the canal have grown into giants of the sea, with dead weights of up to 240,000 tons and lengths approaching 400 meters, equivalent to the length of 4 football fields. The presence of these ultra-large container ships and supertankers not only increases pressure on the navigation system, but also makes the expansion, deepening, and modernization of the canal an essential requirement to ensure safe and efficient passage. But despite its vital role, the Suez Canal once witnessed one of the most shocking incidents in maritime history, the Ever Given blockage. On March 23, 2021, the Ever Given container ship was traveling from Malaysia to the Netherlands when it encountered a sandstorm with winds of 74 kilometers per hour as it entered the Suez Canal, causing it to lose control and crash into the canal bank at 7:40 a.m. Satellite images showed the nearly 400-meter-long vessel completely blocking this critical waterway. Initial rescue efforts with tugboats failed. International teams from Smith Salvage and Nippon Salvage were deployed to excavate tons of sand beneath the bow and stern. The Suez Canal shortened shipping routes by 8 to 10 days compared to sailing around the Cape of Good Hope, generating more than $5 billion USD annually for Egypt. However, the area where the Ever Given became stuck had only a single lane, paralyzing the entire canal. More than 370 ships were forced to wait, with 9.6 billion USD worth of goods stuck each day. The incident occurred at a time when the global supply chain was already under immense strain, with severe container shortages further crippling logistics. After nearly 150 hours, the Ever Given was finally freed thanks to high tides and 14 tugboats. But the surge of vessels arriving at major ports triggered a chain reaction, causing delays, higher shipping costs, and exposing the fragility of global trade when 12% of the world's cargo volume depends on this canal. To free the Ever Given, which weighed more than 200,000 tons, the salvage teams had to combine 4 solutions simultaneously. The bow was deeply embedded in the canal bank, so dredgers and excavators had to remove thousands of cubic meters of mud and sand to reduce pressure. At the same time, more than a dozen high-powered tugboats used 360-degree thrusters to push and pull the ship back into alignment. The crew continued pumping ballast water to reduce weight, helping the vessel rise higher. Finally, the rising tide provided the decisive moment, allowing the combined pulling force to free the ship. It is from these operational challenges that the story of Suez opens up a broader perspective. Compared to Panama, how do the world's 2 largest canals differ in the way they operate? Although it is a man-made sea route that brings enormous time and cost, the Panama Canal operates under extremely sensitive conditions. To reach Panama City on the Pacific side, each ship must pass through narrow stretches, limited visibility bends, and the entire complex lock system, where an error measured in centimeters can lead to disaster. For this reason, the Panama Canal holds a unique role in the global maritime industry. It is the only place where the captain is required to temporarily hand over control of their ship to someone else. This authority is transferred to the praetikos, the canal's professional pilots, who undergo years of training and practice to master every meter of the canal, every current, wind speed, depth level, valve location, and lock operating mechanism. Throughout the entire transit, they are the ones fully responsible for steering ships weighing tens of thousands of tons through the canal's most treacherous sections. During normal periods, up to 40 ships may cross the canal each day, carrying around 600,000 tons of cargo. However, this system depends entirely on freshwater from Lake Gatun, making the canal vulnerable to climate change. Although it is more than 110 years old, the Panama Canal remains an irreplaceable link in the international trade system. To visualize this clearly, imagine a massive container ship traveling from the Atlantic to the Pacific. Without the canal, the entire American continent would become a wall blocking its path. The only option then would be to sail around the treacherous Cape Horn adding up to 15 extra days at sea and consuming thousands of tons of fuel. The canal, 6% of global trade, including energy, consumer goods, agricultural products, and industrial components, is transported faster and more cheaply, helping maintain the continuous flow of goods between Asia, North America, and Europe. For that reason, any disruption in Panama can create a domino effect on transportation costs, logistics, and global supply chains. Even to this day, the Suez Canal remains one of the most important strategic assets for Egypt and for global trade. With its unique position connecting the Mediterranean Sea and the Red Sea, Suez shortens maritime routes by 7,000 to 10,000 kilometers, allowing thousands of ships each year to save time, fuel, and transportation costs. As a result, 10 to 12% of global trade, including oil, natural gas, industrial products, and consumer goods, directly depends on this waterway. For Egypt, Suez is a leading source of stable foreign currency revenue, generating billions of USD each year and creating hundreds of thousands of jobs in port operations, logistics, maritime services, and supporting industries. The Suez Canal also drives urban development, expands infrastructure, attracts foreign investment, and strengthens Egypt's geopolitical role as a gateway connecting three continents. More than a century has passed since its inauguration, yet the Suez Canal remains a vivid testament to humanity's ability to conquer nature. From a harsh desert once deemed impossible for a waterway, Suez has become a vital artery of global commerce, handling up to 14% of the world's cargo flow. Every ship that passes through here not only carries products, but also embodies the story of the vision and immense cost behind a monumental engineering feat. From the 19th century workers who dug each meter of earth by hand, to the giant dredgers that continue maintaining this vast canal today. In the modern world where supply chains are tightly interconnected, even a small incident at Suez can send shockwaves across the globe, as the Ever Given crisis demonstrated. This only highlights the canal's extraordinary role, small on the map, yet possessing an influence far beyond Egypt's borders. And now, a question for you. What do you think about the Suez Canal? Is it an engineering marvel, a strategic choke point, or a symbol of humanity's ambition to carve pathways through the impossible? Share your thoughts and continue following Mandarin Tech to explore the great works that have shaped our world.